Alright people, how you all doing? I hope you're all well. Welcome back to the fish room. As you can see above my head, there's been yet more developments which I'm going to talk to you about, but not in this video, because in this video I want to discuss my aeration system. The current aeration system, by what means it's running at the moment, and how I plan to develop it. So come with me and let's get to it. Sorry, I need to take you with me. So come with me and let's get to it. So guys, this is the pump I'm presently utilizing. It's the hose lock 4500L, which essentially means that there's about 4500 litres in the hour. Fairly powerful pump. I'm fairly happy with it, and it certainly has the capacity to push air into the 15 to 20 odd tanks and tubs that I have going at the moment. So no issues with the pump itself. The problem that I'm still experiencing though is that I don't feel like the pump effectively aerates the tanks in the fish room. The reason I say that is if you have a look at this manifold here, it's got several taps on it, and over half of them are not being utilized, or about half of them are not being utilized whatsoever. And the reason for that is if I were to plug in hoses and actually utilize those, what you'd find is the pressure in all of the other tanks would start to drop. So we certainly don't want that. I feel like I've all got the tanks at the right level of aeration that I would like. I don't think this is a fault of the pump itself, because like I say, it's a fairly powerful pump. Rather, I feel like I'm losing pressure, and I'll explain why. So one of the reasons why I feel like I could be losing pressure is the fact that the length on the air tubes is significant. For example, on this manifold here, which is almost fully utilized, there's a considerable length of air tubing that feeds these tubs here, and likewise even some of the tanks on that side. And likewise, the ones running to the right here would end up supplying to these tanks here. Now, if it was exclusively this tank on the far left, not really an issue, but if you consider the fact that actually it's feeding this whole shelf, it's got a significant kind of air tube that runs especially to that tank on the far right. So that's one of the reasons I feel like pressure is being lost. In addition to that, we've got several areas where there's joints. Now I sometimes feel like, for example here and on the manifolds themselves, I hear air coming out of here. So it's actually not sealed airtight. So what you find is you get air coming out of wherever there might be a joint. Sometimes this chap where it connects here will just pop off like that, and what ends up happening is you end up losing pressure in all the tanks. Now if this was the only problem, I could get around it just by gluing the joints, but like I say, the extensive pipe work I think is leading to the loss of pressure. So how do we go about resolving this problem? Well, what I've decided to do is to put in the closed air loop system. So that essentially involves using pipework that runs along the top of the room. So you've got a loop of pipework, and then subsequently you just drop air lines into every tank using the taps that you then drill into that loop. So I'm going to be doing that, and in part taking you along in terms of what needs to be done to make that happen. I'll be transparent and tell you that I've already started this. I just felt like it was something that needed to happen, and I didn't really like the idea of delaying it. So I essentially started it. So to some extent I'll be talking about it retrospectively. I'll talk you through some of the essentials that you need to know when you're considering implementing a system like that, and some of the problems that perhaps I came across and how I overcame them. Now for you eagle-eyed viewers, you would already notice that there's been some changes to the fish room, and for those of you who haven't noticed, let me just introduce you to the change. Now if we pan around here, what we can see is the fish room is significantly larger, and the reason for that is in the past I've had this heat blanket run from this point here to that point over there. So essentially it's been a wall that's divided this half of the fish room. So almost where that pipework is there, that's where the heat blanket was. Everything to the left of that pipework was the working part of the fish room, essentially outside of the fish room, but it's now been opened up. Looks significantly better, but as I knew, and it was part of why I was so reticent to do it, is I would essentially be heating a much larger area, which would not only be more costly but also not be as effective. Presently, room temperature is sitting at 22.4, whereas in the past I've had this at 25. I have got a solution for that, but we'll have to consider that in another video. Anyway, just for now, if we focus on the aeration, so the idea is the pump will sit on this shelf up here instead of being down there on the ground. The air is then pushed into this pipework which loops around the fish room. So if we just follow it around, it goes across there, across the room there. And just while we're at it, some of you may have noticed there's an air ventilation system here which I've done some work on. Again, that's going to be a separate video. It had to come around the pillar, so I've had to put a joint, another joint in there to send it across towards the bottom of the room. Again, now they say every time you put a joint in, you reduce the pressure within the system. What you'll find is you have to put joints in certain places in order to keep the loop running. So it then goes across the room here. Now I could have taken this point, I could have possibly gone from there to there and maybe just had that pipe extended to the end and then stopped off at the end there. But I just felt like that would then fall outside of the loop, so I decided to continue the loop this way and then back towards where the pump is. Now what you can see in certain places is that the PVC pipe work tees off, comes down, there's a stop at the end, and I've actually drilled taps into the PVC pipe itself. On this side here, again it comes down but then just opens up. Now that is not going to remain open like that. In fact, what I plan to do is put an extension on it and essentially connect it to this manifold. So there will be one place in the fish room where this manifold continues to be used, and then there's the employment of a different method where there wasn't a necessity to have a lot of taps. I just drilled into the PVC itself. Now I had considered putting a T-junction here, putting a similar PVC pipe running from there across to the wall there and then down, and then putting another T in there, having a PVC pipe running across. It's certainly something I'm going to consider perhaps for next weekend. But as you can see, I've used hooks in the ceilings as I like to do, and then subsequently used zip ties, 2 zip ties to create a loop. I need to clean this up. I will be cutting off the excess zip ties. The pipe work, if we just take a second to talk through the pipe work, we're talking 32mm PVC pipe. I think they're drainage pipes. That's just over an inch in terms of the size of the pipe. It's push fit. If they work, then great. If not, I'll end up gluing the joints. So I think the most difficult part really of putting this system in place was not necessarily measuring out the lengths of pipes and things like that you might need, because you can almost get whatever you need in excess and then return whatever you don't use. So that's not necessarily difficult. I think the most difficult part was taking a PVC pipe that was perhaps, as you can see here, 5mm on this one here. So in this case here you've got a 5mm pipe, and taking that into a pipe that's essentially 32mm, so significantly larger. I was having problems sourcing adapters, certainly not available in the local stores in my area. So what I've had to do is I've had to improvise. I essentially would need a fix like that in 2 positions, one there where the outflow from the pump itself goes into the PVC pipe, and there an attachment where it goes from a big pipe into a small pipe. So how I've managed to get around that, I've fashioned my own adapters. So if you have a look at this standard end cap that you get at the end of a 32mm with a plastic flexible hose in it. Likewise the end cap, but in this case with a PVC, a smaller PVC pipe. It looks bigger than 5mm. So it was fairly straightforward. You got your end cap, and I fortunately had these even prior, so I haven't had to go out and purchase these. But essentially they're drill bits that will drill holes within a range of sizes. I've essentially put that on there. As you can see, that's that. I've then just drilled down into the cap itself, bored the hole. Now the thing to remember here is you need to stop every so often when you're drilling and essentially test the size of the hole. What I mean by that is you've got your pipe to hand and you try to push it through the hole you've created. If it's not big enough, you then continue drilling down a little bit further, and you do that again and again until you're able to push that pipe or that flexible hose into the cap end. And then subsequent to having done that, all you do is you take a bit of PVC cement and you essentially kind of glue around the end of it. This one essentially will connect to the pipe here, and this one here will connect to the pump itself. This end will end up going into the PVC pipework, the start of the loop system, and this will end up going into a flexible hose, as you can see is the situation right now. Alright guys, I've just disconnected the air pump and I will get to reconnecting it again as soon as possible, but I just wanted to bring your attention to how eerily quiet the fish room is now. Look how calm the fish are. It's still spooky quiet, guys. So calm. Anyway, back to the pump. So what you can see here is I've attached the flexible hose to the pump outlet itself. I've used a Jubilee clip to tighten it, make sure there's no air leaks, and this end here will be plugged straight into the loop system, the start of the loop system. So let's get that done now. Guys, I've put the pump on the shelf that I created for it, and look what's happened. Essentially the shelf has started coming away from the wall. Thank God this happened while I was around and not kind of overnight or anything like that. So clearly the shelf or the screws used for the shelf was inadequate. So what I'm going to do for now, I'm just going to place it on this rack I've got here and almost do a U-loop that kind of goes back again to the start point there. Not ideal, but yeah, that could have ended in disaster. So I'm so thankful that it kind of started to give way straight away. There you go guys, a much longer hose on there now. One little tip, if you struggle to get the flexible hose on there, just heat it a little bit, which makes it more pliable and it's easier to push on. Alright guys, so as you can see, that's now in place. The rack is in a far better position to be able to hold up this pump, take the extra weight, than this damn shelf was. Again, I'm extremely thankful that that didn't give way overnight or something like that. It could have ended up quite badly, but it didn't damage the pump, make all kinds of racket in the middle of the night. So I'm glad it happened while I was here. Just gonna do the other end now. So just gonna finally connect this manifold to that and then switch it on and see if it works. All right guys, so after all of that talk about how great the hose lock was and how powerful it was, now it's a good pump, I'll give it that, but when I plugged it into my loop system, it's failed to deliver. It's failed to deliver. Look, we can't be having that. We can't be failing to deliver. So what I'm now having to do is drive down to the aquarium to see if I can pick up a more powerful pump. Am I surprised? No. Am I disappointed? Yes. The reason I'm not surprised is it was pretty much running at optimal capacity with the old setup that I had, and the idea of employing this was to try to improve that. But clearly there's a lot more space in the pipe work with the 32mm pipes that now need to be filled before we start getting pressure in the airlines. So I'm not especially surprised at the fact that it's not got as much pressure in the new setup. In the interest of progression and development, as the fish room's getting bigger, there's more tanks in it. I need to invest that money in order to be able to run the fish room at its new capacity. It's as simple as that. Guys, this project's turned into a bit of a nightmare. The fish room's looking a right mess at the moment. This pump is not enough. Bought this one here. Now it turns out this one's too loud. That is going to drive me insane. Anyway, I've switched it on for now. It certainly does the job. It's got all the capacity I need and more. All the tanks are running. All three in there are running. So every single filter is running, other than those that just kind of need balancing out. But yeah, I really have to kind of do something about this noise if I'm going to use this pump. Right, so just to give you a look at what the actual setup is like, even though I'm talking about perhaps changing this up now because of the level of the sound or the noise. I won't call it a sound. Sounds can be pleasant. This is just brutal. So there we are, there's the pump itself. You can see which one it is. This the Halia ACO300A. It's definitely got more than enough in terms of capacity, but that noise is just horrendous. Now as you can see, I've got flexible hose on it. Runs from there, goes all the way up, and then connects to the loop system. Alright guys, so as I've explained before, this pump is just way too loud. Way too loud. You can feel the vibrations. It's an absolutely horrendous sound. I'm not entirely sure what you would use these pumps for, but they're certainly no good for the purposes of a fish room, in my opinion. They're just way too loud. Try to resolve it. Been massively unsuccessful, as you can hear. As it's witnessing to you, it seems to have got even louder, as if that was even possible. So what I've had to do is invest in a new pump. It's this one here. So I'm gonna plug it in before this noise from this pump drives me absolutely bonkers. So here we are guys, we've got the three pumps side by side. In the first instance, you've got the hose lock 4500L, which essentially means it does 4500 liters in the hour. Per minute, that's 75 liters per minute. So moving on from that, you've got the pump that I've been utilizing just now, the very noisy one. Now this is a compression pump, which is different to this one here, which is a linear diaphragm pump. This is a compression pump. I'm not entirely sure what use they make of this, given the amount of noise that it produces. I can't imagine anybody is able to sustain that level of noise for any length of time. So although this pump is significantly more powerful, and to give you a comparison, this is a 4500 liters in the hour. This one here is 14,500 liters in the hour, so more than 3 times as powerful as this one here. But again, the downside with this compression pump was the fact that it just produced too much noise, a horrendous noise, and you even felt the vibrations. Now this is a pump that I've just gone out and purchased. It's a similar pump to the original one that I had, in that it's a linear diaphragm pump. In terms of a size comparison, you can see it's bigger than the original pump. Now as I said, the original pump pushed out something like 4,500 liters per hour. Whereas this one pushes out something like 8,400 liters per hour. It's 140 liters a minute, as you can see from the box here, and apparently it's just above the sound of a whisper. I mean, that's what sold it for me, after having gone through a couple of days of hearing this guy just tear through my ears. I just couldn't deal with the noise anymore. The Charles Austin pump advertised themselves as 45 decibels. So let's see if it lives up to expectations and lives up to its marketing. Alright guys, so that's a new pump now installed. I haven't heard this myself. We're literally going to hear this for the first time together. So let's push this in and see how it sounds. Oh my god, what a difference. Definitely quieter than even my original pump. That's actually quite pleasant, given the fact that even these small air pumps make quite a bit of sound. The sound emitted here is actually very pleasant. I suppose it might help if I stop talking for a minute and let you actually hear the pump. Unbelievable. Anyway, definitely excited by the level of the sound, definitely excited. Now the next thing is just to see if it's doing what I need it to do, which is supplying air to all of the tanks. Yep, we definitely got air all around there. Definitely got air. Like I said, the fact that this one's only leaking small amounts of bubbles is just because of a balancing issue. They all seem to be working here, all three of them, because all three sponge filters are working in that tub there and across these tanks. And the last tank over here, you can see both air pumps are working. Got loads of additional capacity because not only have I got air seeping out from over there, but if you come to the manifolds here, I've actually got quite a few of these open, even though they're not actually doing anything. So I've got at least 6 or 7 open that aren't being utilized. So I'm really pleased with this pump. All I need to do now is clean up the mess. It's time to do a little bit of work now. Excitement's over, we're operational once again, and it's a case of getting back to business as usual.